One day will come when no antenna on Earth, not the one in California, not the one in Spain, not the one in Australia, will receive any signal from Voyager 1. There won't be a warning, there won't be a countdown, just silence. A machine that has been talking to us since 1977, that has shown us Jupiter and Saturn, that has left the solar system behind, will finally go quiet. In this video, we're going to talk about what actually happens in that moment when Voyager 1 falls silent forever. Will the spacecraft itself even know its power has run out? How is NASA preparing for this moment, and what happens to this spacecraft after that silence sets in? If you enjoy real, emotional, and scientifically accurate stories about space missions, make sure to watch this video to the end. First, it's important to understand that Voyager 1 will never go silent because of some accident or malfunction. The reason is simply this: it will run out of power. Voyager 1 doesn't use solar panels because so far from the Sun, solar energy simply doesn't work. Instead, it uses a radioisotope thermoelectric generator, or RTG, which generates heat from the radioactive decay of plutonium-238 and converts that heat into electricity. This is a very reliable power source, but the decay of plutonium is itself a natural process that can't be stopped. With every passing year, Voyager 1's available power drops by roughly 4 watts. This power decline is exponential, meaning it doesn't decrease at a fixed rate, but follows the half-life of plutonium. Plutonium-238 has a half-life of about 87.7 years, meaning every 87.7 years, whatever plutonium remains loses half of its radioactivity. Almost 49 years after its launch, Voyager 1 has already lost roughly a quarter of its original power output. This means that as time goes on, losing each additional percentage of power becomes more critical than the last, because the remaining margin keeps shrinking too. It's important to understand that 4 watts sounds like a tiny amount, less power than a normal LED bulb. But for Voyager 1, those 4 watts make a huge difference every year, because the entire spacecraft, its heaters, its instruments, and its transmitter are all running on a very small total power budget combined. As this margin keeps shrinking, NASA's engineers have to decide every year which system or instrument to shut down, so the remaining ones can keep running. What's interesting is that this whole process isn't some sudden or panicked decision. The Voyager mission's science and engineering teams sat down together years ago and decided the order in which the spacecraft's instruments would be shut down. Both spacecraft, Voyager 1 and Voyager 2, originally carried 10 identical scientific instruments. Over time, 3 instruments have already been shut down, such as the Planetary Radio Astronomy Experiment, which was turned off a long time ago, because it wasn't as necessary during the interstellar phase. How this order was decided was itself an interesting process. Engineers and scientists together evaluated which instrument was providing the most scientific value, which instrument was consuming the most power, and which instrument, if shut down, would cause the least damage to the mission's overall goals. This was a kind of triage process, much like a doctor having to decide, with limited resources, which patient to treat first. Before every instrument shut down, the teams debated the decision for months, sometimes even years, so they could arrive at the best possible outcome. In February 2025, NASA shut down Voyager 1's cosmic ray subsystem to conserve power. Then in April 2026, another big step was taken. Voyager 1's low-energy charged particle instrument, known as LECP, was also shut down. This instrument had been working almost without interruption since 1977, almost 49 years, measuring ions, electrons, and cosmic rays coming from the solar system and the galaxy. The shutdown command was sent from NASA, and it took roughly 23 hours to reach Voyager 1, and then the shutdown process itself took about 3 hours and 15 minutes to complete. Interestingly, a small part of this instrument, a motor that rotates the sensor so it can scan in all directions, is still running because it only uses 0.5 watts, which is so little that there's no benefit in shutting it down. Now Voyager 1 has only two science instruments left that are active: the magnetometer, which measures the local magnetic field, and the plasma wave subsystem, which detects oscillations in interstellar plasma. Both instruments were considered essential because they measure basic characteristics of interstellar space that no other spacecraft can measure. Voyager 1 is still the only object that can send data directly from this location. The same process is happening with Voyager 2, though on a slightly different timeline. Voyager 2's LECP was shut down back in March 2025, and its cosmic ray subsystem is scheduled to be shut down in 2026. NASA's engineers estimate that if everything goes well, both spacecraft could operate with their last remaining instruments into the 2030s. But they themselves acknowledge that with technology more than 47 years old, unforeseen challenges could shorten this timeline at any point. Now the question is, before these last remaining instruments have to be shut down too, what will actually happen? According to NASA's plan, as power keeps decreasing, the teams will also have to shut down the heaters, and this is a major risk because the temperature of interstellar space is so low that if Voyager 1's instruments and electronics get too cold, they could stop working permanently, even if they still have power. This is why in these final years, NASA's engineers are maintaining a very delicate balance, keeping the heaters on just enough to keep the spacecraft alive without using so much power that the remaining systems have to be shut down. The temperature of interstellar space is so extreme that Voyager's components, which were originally built with 1970s technology, simply surviving there is an achievement in itself. Engineers have made several surprising discoveries before, finding that parts of Voyager, which were expected not to function in such cold temperatures, turned out to be more resilient than expected. This is further proof that the engineers of the 1970s built this spacecraft so carefully, so robustly, that it's still withstanding extreme conditions today. As long as Voyager 1 has enough power to run its transmitter, it will be able to send us a signal, whether that's science data or just a basic "I'm alive" type of engineering signal. But a day will come when the power drops so low that the transmitter itself won't be able to stay on. At that point, Voyager 1's signal reaching Earth will stop forever. Here's an important technical detail worth understanding, figuring out that final moment won't be as simple as it sounds. Voyager 1's signal still takes about 23 hours to reach Earth, and by November 2026, the distance will have grown so much that Voyager 1 will be 1 light day away from Earth, meaning its signal will take a full day to reach Earth. Because of this, when the spacecraft actually falls silent, NASA won't find out immediately. They'll only know that no signal arrived at the expected time. And because the light speed delay is so large, Voyager 1 may actually have gone silent hours or even a full day before we find out, and we'd only learn about it much later. This 1 light day milestone will itself be a historic moment, separate and apart. Until now, only light hours were discussed when talking about Voyager 1's distance, but as soon as it reaches a full light day's distance, this will become a new benchmark for human understanding. Humans have never sent anything so far that its signal takes a full day to come back. This itself is a reminder that Voyager 1, even before its silence, keeps crossing new milestones. The first time an expected signal doesn't arrive, NASA's team won't panic right away, because this has happened before in Voyager mission history, when communication was temporarily disrupted. In October 2024, Voyager 1 suddenly shut down its primary radio transmitter, known as the X-band, and switched to its much weaker S-band transmitter, which hadn't been used in over 40 years. Because of this, for a few weeks, NASA's team didn't get any useful data from Voyager 1, and there was confusion about the spacecraft's status. But after a few weeks of effort, NASA's team brought Voyager 1 back to normal operations, and the X-band transmitter became active again. Incidents like this are an example of how the Voyager team always takes a wait and retry approach, because this spacecraft has come back from situations like this many times before. But when the actual final moment arrives, when power has dropped so low that restarting the transmitter simply isn't possible anymore, that's when NASA's team will gradually realize that this isn't a temporary glitch, but permanent silence. The Deep Space Network, which consists of 3 large radio antenna complexes in California, Spain, and Australia, will probably keep listening in Voyager 1's direction for some time, hoping to catch some weak signal, like one last faint whisper. But if no signal comes, NASA will eventually have to officially accept that contact with Voyager 1 has ended forever. This kind of continued listening by the Deep Space Network is itself a resource-intensive process, because these 3 antenna complexes also support many other active missions, such as Mars rovers, other planetary probes, and deep space telescopes. Because of this, a point will come when NASA will have to make a practical decision about whether to keep allocating antenna time to Voyager 1 or not, especially if no signal is received for many months. This decision will itself be emotional because it would mean officially accepting that no hope remains. This moment won't just be a technical event, it will be an emotional moment for NASA and for space enthusiasts around the world. For many scientists and engineers who have spent their entire careers with the Voyager mission, this will feel like a long old friendship coming to an end. Voyager project scientist Dr. Edward Stone, who led this mission for decades, was so emotionally attached to this mission that he continued following Voyager's updates even after his retirement. Similar feelings, to greater or lesser degrees, exist across the entire Voyager team. This emotional attachment isn't limited to senior scientists alone. The Voyager mission has run so long that several junior engineers who joined this mission at the start of their careers have now reached senior positions, having spent their entire professional lives with this one mission. Some even have parents or mentors who also once worked on the Voyager mission, meaning this mission has literally been passed down from one generation to the next, and when it goes silent, it will feel like a part of many people's professional and personal identity has ended too. We've seen examples of moments like this in other space missions too. Take NASA's Opportunity rover, which worked on Mars for years. When a massive dust storm covered its solar panels and drained its power, its final transmission was a simple, standard engineering code. But when the media translated this data in a poetic way, a famous line was created. "My battery is low and it's getting dark," which the rover never literally said. But this line touched the whole world emotionally, and it went viral. This example is a good illustration of how humans turn technical events into emotional narratives, especially when they're related to a machine that people have followed for years. Opportunity's planned mission was only 90 days, but it stayed active on Mars for almost 15 years, much like Voyager, which ran many times longer than its original 4-year mission. That's why, whenever these missions reach their end, people treat them not just as machines, but almost as a companion in its final moments. In the same way, when Voyager 1 sends its final signal, even if it's just a routine engineering code, people will surely remember it in some emotional way too. Another example is the Cassini mission, which orbited Saturn for years. When its fuel started running out, NASA decided to give it a controlled, dramatic grand finale. Cassini was deliberately sent into Saturn's atmosphere, where it burned up so that it would never crash into one of Saturn's moons and contaminate it. Cassini's end was a planned, dramatic event where the spacecraft kept sending data right up to the final second. Voyager 1's end will be the complete opposite. No dramatic crash, no controlled destruction, just a quiet, gradual fading, like a battery slowly running down. Here are some common questions people often ask. Could NASA deliberately shut down Voyager 1 the way Cassini was given a controlled ending? There's no real need for this because Voyager 1 isn't close to any solar system object that it could contaminate, so NASA will let it run naturally for as long as possible without any rush to shut it down. Will we be able to know exactly when Voyager 1 went silent? No. Pinpointing the exact moment will be difficult because, as we discussed, the signal delay means we'll only know that contact wasn't made at an expected time, not the exact moment itself. Could someone turn Voyager 1 back on after it goes silent? Absolutely not, at least not with the current level of human technology. No spacecraft can travel that far to physically reach Voyager 1 to repair it or replace its battery. Once the power drops so low that the transmitter shuts down, it will stay off forever. Now, here's an important question. Once Voyager 1's signal is gone forever, what will physically happen to the spacecraft? Here's a very important thing to understand. Voyager 1 itself won't be destroyed. It will simply keep traveling at its current speed of about 17 kilometers per second in its current direction forever. There's nothing in space that can destroy it. No air, no friction, no erosion like we see on Earth. There'll just be one difference. We'll never know what it sees on that journey, what it passes by, what it experiences, because its voice will have gone silent forever. This is a strange kind of continuity in itself. A spacecraft's life doesn't end the moment its voice ends. Voyager 1 will continue its physical journey on its gravity-driven trajectory exactly as we discussed earlier when talking about its future over trillions of years, passing through the Oort cloud, passing close to some star, completing an orbit around the Milky Way. The only difference will be that we won't be able to watch any part of that journey anymore. We'll only be able to predict what's happening through the calculations of physics without any confirmation. It feels very strange to think that the machine we can still talk to, that we can still send commands to, whose every update is still news today, will one day be exactly the same as it is now. We'll just have lost contact with it. Voyager 1 won't lose its life, we'll lose its voice. This is a very philosophical distinction. Is a spacecraft alive as long as it can talk to us, or as long as it physically exists? For NASA, officially ending this mission will also be a complex process. When contact with Voyager 1 is lost, it doesn't mean the entire mission will suddenly be shut down. The Voyager mission team, which has been analyzing this data for decades, will continue studying the data that Voyager 1 sent throughout its lifetime for years, even decades, to come. Voyager's decades of calibrated data are already publicly available in NASA's Planetary Data System, and researchers will keep analyzing this data in the future, looking for new ways to extract new insights from it. That's why the science of the Voyager mission won't end the day the spacecraft goes silent. Only the arrival of new data will stop. Just as historians keep drawing new insights from records left behind by ancient civilizations, even centuries later, Voyager's data will similarly become a valuable resource for future scientists, to be studied again and again with new tools and new analytical techniques. Patterns we can't see in Voyager's data right now might become clear 20 or 50 years from now, when we have better analysis tools. In this sense, Voyager's legacy won't end on the day it goes silent. It will actually enter a new phase from that day onward. It's also worth thinking about that before Voyager 1 goes silent, Voyager 2 will also be reaching its final phase on a similar timeline. Both spacecraft, which were launched together, will be writing the final chapter of their missions around the same time too, though their exact timing might differ slightly, depending on how quickly their power is decreasing and their instruments' exact configuration. It's also interesting to think that if Voyager 1 goes silent first, Voyager 2 will keep talking to us alone for some time, humanity's last direct link from interstellar space. At that point, the world's attention on Voyager 2 will become even more focused, because it will be our farthest-reaching and last active deep space ambassador. And then, when Voyager 2 also goes silent, that day will mark the literal end of an entire chapter in humanity's deep space exploration. There's another important thing. Once Voyager 1's transmitter permanently shuts down, it also means we'll never know what happened next. Did Voyager 1 pass through a dust cloud? Did its trajectory change due to some gravitational interaction? Did its golden record slowly start to erode? We'll never get direct answers to any of these questions. We can only calculate, using the formulas of physics, what should be happening, as we discussed earlier when talking about Voyager's future over trillions of years, but actual real-time confirmation will be gone from us forever. That's why this moment, when Voyager 1 goes silent, isn't just a technical milestone, it's also a symbolic moment that will mark the end of an entire era of humanity's deep space exploration. The Voyager missions are our first, and still our longest, direct conversation from a place outside our solar system. When this conversation ends, we will, in a way, lose our farthest-reaching voice, even though that voice will physically still be there, forever, traveling away from us. It's also interesting that NASA is preparing for this moment, both emotionally and practically. Engineers are already discussing how to document the moment when final contact with Voyager 1 happens, how to celebrate the entire journey this spacecraft has taken. Many people also expect that the day this official news comes out, it will be a huge emotional moment for space enthusiasts, scientists, and journalists around the world, much like hearing news of the passing of a very old, respected person. Some people also wonder whether NASA will celebrate or mark Voyager 1's final moments in some way, like sending a special commemorative message. No official plan has been announced about this yet, but the Voyager mission team has always treated this mission not just as a technical achievement, but as an emotional legacy for humanity. So it's entirely possible that when this moment arrives, NASA will mark the occasion with a proper tribute, rather than just a routine mission-ended announcement. Many people also expect that when this day comes, it will be celebrated as a global event on social media, on news channels, and across science communities. People will share messages, tributes, and memories about their connection with Voyager. For many people who have followed every piece of Voyager news throughout their lives, from the Jupiter flyby to its entry into interstellar space, this day will feel like the end of an era, because Voyager hasn't just remained a mission, it has become a symbol of science and exploration for an entire generation. So the next time you read some news about Voyager 1, whether it's a new instrument shutdown or some communication glitch, remember that every such piece of news is bringing us closer to that final day. This is something we know is going to happen, but we don't know exactly when. And when that day arrives, it will mark the end of humanity's longest, farthest-reaching conversation, a conversation that began in 1977, and one that will live on forever in our collective memory, no matter how far Voyager 1 itself travels away from us. This is itself a unique kind of human experience, watching the end of a machine that we built, that we launched, that we followed for decades, but in a way that isn't like any normal death or ending. No crash, no explosion, just a slow, gradual fading, like an old radio station whose frequency slowly turns into static. Perhaps that's why this ending feels so thoughtful, so reflective, because it gives us time to remember this entire journey, to appreciate it, and to understand the effort that went into keeping a machine alive for so many years. If you enjoyed this video, please hit like, subscribe to the channel, and let us know in the comments. When that day comes, when Voyager 1 finally goes silent forever, what do you think the world's reaction will be? See you in the next video with another amazing space story.